All right, and we're back to it. So, Part B, Chapter 11, Section 2. Let's keep learning. So, the key word in this next example is the word collinear. We need to know what that means. So it says determine whether the following 3 points. So we have 3 points out in space, and we want to determine if these 3 points are collinear. In other words, what we mean is, do they all reside on the same line? Interesting. So how can we do this? Well, the way I'm going to do it, I can think of a few ways of approaching this, but I'm going to go ahead and, since we're not really, since we're not really told about, we're given points in space. We're not talking about vectors, but I'm going to think about this as two vectors. I'm going to think about a vector moving from P to Q, and I want to think about a vector moving from P to R. Does it make sense to you? I just arbitrarily chose P as an initial point, and here's what see if you and I can agree here. So, if this is P to, if this is, I'll see if I can draw it a little bit better. So, if this is point P, and this is point Q, and this is point R. I know this we're in space, but see if you can wrap your head around what I'm trying to think of. So if we have a vector from P to Q, if indeed they are collinear, then I should be able to scale this vector, right? Scale it and get it all the way out from P to R. I should be able to multiply by something by that to move it all the way out to P to R. And that alone, is enough to tell me that they're scalar multiples. They are parallel, and therefore they're on the same. They reside on the same line. So, but first things first, let's actually build. Let's build P to Q, P to R. So I'm going to go ahead and go through this quickly. All I'm going to do is get the component form. So I'm not going to take my time showing you how to do component form, since we've already learned this multiple times. So P to Q would be the following vector. P to R would be the following vector. All right. So P is my initial point, and what I know is that P, Q, R are collinear, right? If P to Q is parallel to P to R. All right. So I can make the statement about them being collinear. I just have to prove that that these two vectors are parallel. All right. Well, how do we do that? So there should be some constant out there. So I got 1, 3, -3 equals, now there should be a constant out there that would allow me to build one vector from the other vector. All right. By the way, it doesn't matter where you place this C. I mean, you can place it over here if you want to. That part doesn't matter. So, ready? Let's do it. Let's figure it out. So let's set 1 equal to 3C. Let's set 3 equal to 9C, and proceed. 1 is equal to 3c, 3 is equal to 9c, negative 3 is equal to, what is that, negative 9c. And the only thing I care about is that when I solve for c, I get the same value. Okay? So in this case, c is equal to, what, 1/3. In this case, c is equal to 1/3. In this case, c is equal to 1/3. So at this point, I know that they are parallel. So I've proven this, that they are parallel, and so then by definition they are collinear. So parallel, thus collinear. Okay. Let's go to the next example. So there's three. For example 6, there's 3 parts. I really want you to highlight part B. This is a very good question for you to keep track of, to have access to. Ready? But let's start with part A. So we're given V, and we're back to this IJ notation. Only now the standard notation, it's IJK, right? Because now we're in space. So what are we trying to do? Well, here's what we're trying to do. It says, can you write the following vector in component form? Well, this is so easy that it could actually be hard for someone. Right? So all I need to know is what goes here, here, and here. Right? Because there should be I, J, K. Well, of course, 4 is going to go first. And I hope that it makes sense that you have 0J here, right? There's no J direction, so that you need to represent that as a 0. And then you would have negative 5 here. Most common mistake is somebody would do this. That's not a vector in space. That's a vector in a plane. Okay? You can't leave out the 0. Now let's go to part B, which is a very good question and one you should take some notes of. So let's start with, let's see if we can understand the question. So in this question, we want to find the terminal point of a vector. Right? So there's some vector out there. This would be its terminal point. We actually want to know what that point is. So we're going to be given the initial point. We're going to be given the vector. We want to be able to find the terminal. All right, so here's the information that we're given. So vector V, in this case, is 7I minus J plus 3K, and the initial point of that vector is negative 2, 3, 5. Okay, interesting. So I don't think we've encountered this before. So here we go. We got this, we got this. How do we get to the terminal? So the way we're going to do this is, if you recall the formula we used to go from component form, let me do something for you to make so that this question's a little bit easier to see. So let's assume that point P is, and I'm just going to make up something here. Let's say it's p sub 1, p sub 2, p sub 3. And we'll say that point Q, now this is going to be the terminal, is at Q sub 1, Q sub 2, Q sub 3. I could have used, by the way, I could have used X sub 1, Y sub 1, Z sub 1, X sub 2, Y sub 2, Z sub 2. But I actually wish I would have now, but not that it matters. All right, so let me now, please stay with me. Let's assume that if you were giving these 2 points, P to Q, remember how we could go from here to component form? Do you remember what we would do? It would just be a matter of doing some Q sub 1 minus P sub 1, comma, Q sub 2 minus P sub 2, comma, Q sub 3 minus P sub 3. And then this would equal the vector in component form. Only now we actually have the vector in component form. Or it's not really in component form, but we have the vector. So we'll know what this is equal to. So this is, let me now show you what's going to happen here. So in component form, this would just be 7, -1, 3. And let me now get to where I want to be. So I know the vector. So if I had this information, terminal, initial, I know what should go here. And that should be this vector V. So I know that it's going to be equal to 7, -1, 3. And now, don't you agree with me that I also know point P? So I'm going to plug in the -2, I'm going to plug in the 3, I'm going to plug in the 5. And then I'm going to solve for the others. Ready? Let's go. So what is that going to look like? It's going to be Q sub 1 minus, all right, and that's going to be -2. All right, and then it's going to be Q sub 2 minus, what do I have for P sub 2? I'd have 3. Then it's going to be Q sub 3 minus 5. And this has to equal 7, -1, 3. All right, I hope that you're with me. So at this stage, you're going to set each component equal to each other. So I'm going to set Q sub 1 plus 2 equal to 7 and solve for Q sub 1. So Q sub 1 plus 2 must equal 7. Q sub 2 minus 3 must equal -1. And Q sub 3 minus 5 must equal 3. And you see how we, at this stage, we're not done. At this stage, I can solve for Q sub 1, 2, and 3, and that will be my terminal. All right, so Q sub 1 is equal to, what do we got? 5. Q sub 2 is going to be equal to, add 3, so that's what, 2. And Q sub 3, add 5, so that's 8. So here it is. Here's your terminal. So it's going to be 5, 2, 8. All right, so I hope that made sense. I hope that was easy enough to you. I'm actually going to skip part C because we've already done something like that. Um, you're given a vector, right? I'll give you the answer. I'll do that for you. I'll give you the answer, but I'm not going to do it for you. Um, Here's the vector. Find its magnitude and find the unit vector. It's easy. We've done stuff like that before. So let me erase what I have here, and I'll just give you the answer to part C. I guess one of the good things about having online classes is that you can pause these videos so that the professor doesn't erase the board too quickly when you're trying to copy notes. Of course, that's counterbalanced with the fact that you have every distraction that you can think of in front of you, right? That video game system staring at you, calling to you. Your cell phone is calling to you, right? I get that. All right. So this is going to be the last question for this section. So ready? Let's see some of this in an application. So what do we got here? So we got a television camera that weighs 120 pounds. So here it is. So here's your television camera. We know its weight's 121 pounds, and it's supported by 3 legs, a tripod. What we want to know, right? And if this, we're gonna assume that this is not falling over. We're gonna assume that this is not falling to the ground, breaking. What we want to know is how much force is being exerted on each leg of this tripod, right? How much force is, because we're distributing that 120 pounds, and we want to know how much force is being exerted on each one of those. Ready? Let's jump in. So the way that we're going to do this, so we're using a picture here, and based on this picture, so we're going to assume that this, where my stylus is right now, is point P, and we're going to start to think about vectors, right? We're going to build a vector from each of these legs of this tripod. All right, so let's do that now. Let's build a vector from each. So we want to know there's a force that's being exerted. Let's call the first leg of that tripod P to Q sub 1, and we want to know the force of that. We also want to know the force of P to Q sub 2, and we also want to know the force being exerted on the last leg, which is P to Q sub 3. So first things first, let's build the vector. All right. So this is not bad. You have to remember the direction of the vector, right? Gravity is pulling this camera down to the ground, so we have to assume the direction is important here. So we're going from P to Q. So when we build let's build the vector for each. And by the way, it's already done here. They've already done that for us. But that's simple. You already know how to do it, right? It's just, you're just subtracting in that component form equation. So here's what I'll do for you. It's going to be 0 minus 0, negative 1 minus 0, 0 minus 4. If you were to do that arithmetic, here is the component form of this first vector. Oh, actually, when I first looked at it, I thought that they gave us the vector. No, they actually just give us the point. Now that makes perfect sense. So, okay. So it's just 0 minus 0, 0 minus negative 1, 0. I'm going, am I going the right way? Yeah, so 0 minus 0, negative 1 minus 0, and 0 minus 4. Okay. So I'll go ahead and, here's our first vector. Let me go ahead and do the same thing for the other ones. So it'll be the square root of 3 over 2 minus 0, 1/2 minus 0, and 0 minus 4. So that gets me the square root of 3 over 2, 1/2, negative 4. All right, and one more time. So negative square root of 3 over 2 minus 0. 1/2 minus 0, and 0 minus 4. I'm trying to go quickly and without making silly errors. Okay. So here are my 3 vectors, right, that represent each of those legs of that tripod. And now, but that's not really the question that was asked of us, right? We weren't just asked build a vector for each tripod. No, the question is, can you represent the force that's being exerted on each leg of the tripod as a vector? So remember, vectors, right, they have the magnitude and they have the direction. I hope it makes sense to everyone who's watching this video that at this stage we have the direction, right? We have the direction. We just don't know how much of that weight, right? We got 120 pounds. That camera's got 120 pounds. We don't know how much of that weight is being supported in this direction. So we need to figure out the magnitude of each of these vectors. And how do we do that? Well, let's start with, let's see if you agree with this. We know, let's say that F, right, that's the force, right, no subscript there. F is the force of that camera. We know that to be 120 pounds. Right, I hope that blue shows up okay for you on your end. So let's agree, if it's not falling over, that what we're going to end up with is C multiplied by F sub 1 plus C multiplied by F sub 2 plus C multiplied by F sub 3. And all of this right here should support the weight of that camera, which is 120 pounds. Here's the key part. Let's see. So here's the key part that you might not have gotten unless you've done a lot of these. Let's agree we know what to plug in for F sub 1. We know what to plug in for F sub 2. We know what to plug in for F sub 3. That's easy. The part that might not be apparent is, what do you do here? Well, you might think, well, I'll just say it's equal to 120, but, and that's, I like where you're going with that, but a force is a vector, so we need to represent F as a vector. So F, how would you represent F as a vector? Because that 120 is important, but how do we think about it? All right. Well, can we agree that all 120 pounds is moving downward, right? Negative in the Z direction. Can we agree on that, right? I mean, the camera does. I mean, and the camera doesn't. How do I like? It wants to fall to the ground, so it wants to travel in a negative z direction. It doesn't want to go left to right, right? It doesn't want to go up, side to side. It wants to go in a, in a negative direction of the z-axis. So the way we can represent that is, well, we got 0 for the x and y directions here, and we have all 120, and the keyword is downward, right? So all 120 pounds is in the z direction, the negative z direction. Okay. So at this stage, that's left is I'm going to go to the next page where I have a little bit more room. I'm going to plug in here, here, and here. Plug in for all my forces. And then I'm going to solve for C. So it'll take me longer to write it than it will be to solve it, but hey, that's okay. You can entertain yourself for just a second. I'm actually wondering if I can fit all of this. All right, I know what you're thinking. That no, you can't do it. But you don't know the power that I have. I can fit all of this. Ready? Boom, look at that. Ha. I have to find ways to entertain myself. I have no one to talk to now. I'm just staring at a screen. So just deal with it. You'll be okay. Yeah, there we go. So at this stage, it's time to solve for C. And in fact, this is heck of a lot easier than you initially would think, because notice how, let's look at the x components. 0 plus the square root of 3 over 2 minus the square root of 3 over 2 equals 0. Of course. These cancel. Square root of 3 over 2 and negative square root of 3 over 2. And what we end up with, we got a half plus a half is 1. So 1 minus 1 is 0. So in actuality, all we need to worry about is the z components here. So what does that look like? It's going to look like this. So I got negative 4c minus 4c minus 4c has to equal negative 120. That makes sense? We're just distributing a c and setting it equal to, everything's going to cancel with the x's and y's. And let's finish it up. So that's, what is it, 4, 4, and 4. So that's negative 12c is equal to negative 120. Therefore, c is equal to 10. What does that mean for us? What that means is, if c is 10, then you have 10 f sub 1 plus 10 f sub 2 plus 10 f sub 3 is equal to f. So at this stage, not only do we know, let me go back, not only do we know the direction of the tripod, we also know the force that's being exerted. And I'll leave it at that. I think we pretty much captured everything we need to capture. If you happen to have any questions, just reach out to me. And if not, I'll see you in the next video.